Hello students, welcome to Sankalp Learning. I am your Aishwarya. Today we are going to have session 2 on electrochemistry and we are going to cover some of the important concepts here. Fine. Okay. So let's get started. So here we are going to discuss electrode potential. Now the question is, what is electrode potential? Electrode potential anta andre yenu? So in the previous class, these are some of the important terms regarding electrochemical cells anta anbodu. So electrode potential andre enu? As we had seen in the last class, when an electrode is in contact with its solution. So solution li enirutte, which solution we have taken? Electrolyte antivi now. The electrode, yav electrode tಗೊಂಡಿರ್ತೀವಿ, yav metal electrode tಗೊಂಡಿರ್ತೀವಿ, ಆ metal solution irutte, and that we call it as an electrolyte. Like for example, in Danielson, we had taken zinc rod dipped in zinc sulfate solution, copper rod dipped in copper sulfate solution, right? So zinc rod, which is dipped in zinc sulfate solution, between the electrode and the ion of it in its solution, between the electrode and its ion in the solution, there will be certain potential. That potential we call it as electrode potential. So what is electrode potential? When an electrode is in contact with the solution of its ions in the half cell, in a particular half cell, it has the tendency either to lose electrons or gain electrons, and other mele now half cell we name it as oxidation half cell if it is losing the electron, and we name it as reduction half cell, it is gaining the electron. So here, when electrode is in contact with solution of its ions in the half cell, potential is developed, and that potential we call it as electrode potential. This electrode potential, it is expressed in volts. Now it is an intensive property. Enappa intensive property andre, it is independent of the amount of species in the reaction. The potential difference between the electrode and its ions in solution is called electrode potential, right? And this electrode potential is denoted by capital E. E electrode anta baribodu, or simply you can write E. Fine. So here, if you consider an example of a Daniel cell. So Daniel cell ಬಗ್ಗೆ ನಾವು ತುಂಬಾ ಮಾತಾಡಿದೀವಿ. When we say Daniel cell, it is nothing but zinc copper cell. Zinc copper cell. ಹೌದಾ? Okay, fine. So let us see here. So zinc copper cell ತಗೊಂಡಾಗ, when we take a Daniel cell, zinc copper electrochemical cell ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ, so here you have cathode, electrode. So cathode electrode ಆಗಿ ಏನಿದೆ? There is copper. Cathode electrode is my copper, right? So what is happening in cathode half cell? Cathode half cell alli ಏನಾಗ್ತಿದೆ? Cathode electrode is dipped in copper sulfate solution. So Cu plus 2 ions from the solution, they see the electrons which are coming. They see the electrons which are coming at the copper rod and immediately take those electrons. Cu plus 2 irodrinda, I'll write 2 electrons here. Immediately take those electrons, and that means they go and jump to that rod for taking the electrons. So Cu plus 2 is going onto the rod. So we can see, Daniel cell ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ, after some time, solid Cu gets deposited on that electrode. So there is gain of electrons, therefore cathode. So here what I can say is, so this copper Cu plus 2 ions are taking up these electrons. Therefore I can say cathode rod. So what I can say here, cathode rod is at positive potential. Cathode rod is at positive potential with respect to the electrolyte. It's electrolyte ani. Okay, fine. Similarly, go for anode. Go for anode. So anode hatra enide, there is zinc rod dipped in zinc sulfate solution. So same thing here. So what zinc does? Zinc, being more reactive, so solid form of zinc, it will lose electrons at anode, oxidation, anox. So it will lose electron and become stable Zn plus 2 ion by losing 2 electrons. Yes. So this zinc plus is coming into the solution, leaving electrons on the rod. So leaving electrons on the rod andaga, what I can say, anode rod electrons idave. Anode rod mele electrons idave. So what is that electrons? Negative charge. So I can say anode rod is at negative potential. Anode rod is at negative potential with respect to the electrolyte. With respect to the electrolyte. So in the Daniel cell, cathode rod is at positive potential and anode rod is at negative potential with respect to electrolyte. Yes, so this is about electrode potential. Now, what is this standard electrode potential, which is denoted like this SCP, which is abbreviated as SCP. So, standard electrode potential antandre yenu? All the things at under standard conditions. Andre temperature 298 Kelvin. 298 Kelvin is standard temperature. Then pressure is 1 atmosphere. ಆಮೇಲೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ನೀವು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ತಗೊಂಡಿದೀವಿ, ಜಿಂಕ್ ಸಲ್ಫೇಟ್ ಅಂಡ್ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಇಸ್ ಟೇಕನ್. ಸೊ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಆರ್ ಆಲ್ ಯೂನಿಟಿ ಅಂತಂದ್ರೆ ಏನು? The concentrations are at 1 molar. 1 molar. What does that mean? Molarity. Molarity you have studied in your class 11. I need not go in detail. So molarity, moles per liter. Yes, 1 molar concentration. If all these conditions are satisfied, then we call it as standard electrode potential. So standard electrode potential andre ಏನು? Standard electrode potential andre electrode potential when at standard conditions. Fine, when it is at standard conditions. Now this standard electrode potentials are of two types. They are of two types. Yavappa two types. So what are the two types? One is, I write it as standard oxidation potential. Standard oxidation potential, abbreviated as SOP, and standard reduction potential, abbreviated as SRP. Okay, so how do you represent here standard oxidation potential? Hey, represent marti. Electrode potentials are denoted as E. Yes, let me make that point very clear. Electrode potentials are denoted as E. E electrode anta nodidvi. You can denote it by E. Standard electrode potential is denoted as E naught. Standard andaga we have a naught here. So here we are talking about standard oxidation potential. How do we denote standard oxidation potential? Standard andmele E naught. Here we write m bar m raised to n plus. And how the standard reduction potential is denoted? E naught standard mn plus bar m. Now the question arises, teacher, idu representation nodid takshana, how do we understand whether it is an oxidation potential or a reduction potential? Don't worry much, you need not by heart these concepts. Oxidation andre m bar mn plus amel baratte, reduction mn plus power mn, not required. Please do not by heart it. See, I'll tell you the easy way to remember, how to remember this. See, oxidation anta andre enu? Oxidation is what? Oxidation is loss of electrons. Howda? Oxidation is loss of electrons. So oxidation is loss andaga, if you have a metal, this metal is going to lose electrons, say n electrons, and form n plus charge by losing n electrons. Getting my point? So oxidation potential, standard oxidation potential, from m to it is becoming mn plus. Okay, then what do you mean by reduction? Reduction antandre eno? It is gain of electrons. It is gain of electrons. Andre, you have certain ion, say it is mn plus number charge, it is going to gain n number of electrons and form metal, that is m. So mn plus is becoming m. So m raised to mn plus bar m. This is reduction potential. So looking at the subscript, we will get the idea whether I am talking about oxidation potential or reduction potential. Getting my point? Okay, fine. Next, the important term regarding electrochemical cell is something called cell potential. Cell potential, sometimes we use the term for this. Cell potential is also called cell EMF, electromotive force. Okay. Now, what is the cell potential? Teacher, electrode potential ಬಗ್ಗೆ ಅಂದ್ರೆ ತಿಳ್ಕೊಂಡ್ವಿ, between the electrode and its ion in the electrolyte. What is the cell potential? Cell potential ಅಂದ್ರೆ ಏನು? See, in this entire cell, you have two half cells. The potential difference between the two half cells, or the potential difference between the two electrodes of a galvanic cell or a Daniell cell, is called cell potential. So what is cell potential? It is the potential difference between two electrodes. The potential difference between the two electrodes of a galvanic cell. of a galvanic cell is nothing but cell potential. ಏನಪ್ಪಾ ಹಿಂಗಂದ್ರೆ means electrode potential of cathode. Two electrodes ಯಾವ್ಯಾವಪ್ಪ? Electrode potential of cathode and the electrode potential of anode. The difference between the two is the cell potential, and this cell potential, it is denoted as E cell. It is denoted as E cell. So what is E cell equal to? It is nothing but E cathode minus E anode. It is a E cathode minus E anode. This electrode potential, cell potential, it is measured in volts. It is measured in volts. It is also called cell EMF when there is no current drawn through the cell. Cell potential yavagantivi when there is some current drawn through the cell. EMF yavag use martivi when there is no current drawn through the cell. Otherwise, both the terms mean the same. Okay, fine. Here, so E cell is what now? E cathode minus E anode. Now the question arises, cathode ಮತ್ತು anode, are you talking about the electrode potentials of cathode minus electrode potential of anode ಅಂತ ಅಂದ್ವಿ. Here the question is, cathode ಮತ್ತು anode, are you talking about oxidation electrode potentials or you are talking about reduction electrode potentials? Getting my point? So the question now here is whether oxidation or reduction. Therefore, I'll tell you, by convention, whenever we use the term electrode potential, we are talking always about, whenever we are using the term standard electrode potential or electrode potential, we are always talking about standard reduction potential. Please remember this. Always, by convention, by assumption, we take it as standard reduction potential. So here you can write it as E cell is nothing but E reduction potential at cathode minus E reduction potential at anode. By convention, it is taken like this. Fine. Now comes to the representation. How this galvanic cell is represented. Okay. So representation, how the cell is represented. How do you represent the cell? Fine. Representation. See, a galvanic cell is generally represented by putting a vertical line between the metal and its electrolytic solution. Metal ಮತ್ತು electrolytic solution ನಡುವೆ vertical line ಹಾಕ್ಬೋದು. And so there are two electrodes. So two electrolytes. So between metal and electrolyte, you put a vertical line. And these two half cells are separated by double vertical line. They are separated by double vertical line. For example, if you consider a Daniell cell, reaction ಹೇಗೆ ಬರ್ತಿದ್ವಿ ನಾವು? Zn solid plus Cu plus 2 in aqueous solution gives you Zn plus 2 in aqueous plus Cu getting deposited like this. Correct? So how a Daniell cell is represented? Representation ಹೇಗೆ ಬರೆಯೋದು? So I'll write it like this. You can see here. So I represent it as Zn, a vertical line, Zn plus 2. So if you want, you can be more clear. Zn solid, vertical line, Zn plus 2 aqueous, separated by double vertical lines, which represents salt bridge also. Here Cu plus 2 aqueous solution bar Cu. This is how a galvanic cell or a Daniell cell is represented. I'll give you an example. So let me see how you can do that. Okay. The example is something like this. Copper solid bar Cu plus 2 in aqueous, double vertical line, Ag plus in aqueous bar Ag. So this is cell representation. This is my cell representation. What do you understand from this? What do you understand from this? So what do we understand? The first point what I understand here is, it is an electrochemical cell which includes copper and silver. So copper and silver are involved. Fine. Then through this cell representation, what we are getting, what information we are getting? You can see Ag plus is becoming Ag. So Ag plus yavaga Ag agatte? When it gains one electron, it becomes Ag. Am I right? So gain of electron andre, what does it mean? Gain of electron means reduction. So reduction yellagate, red cat, yellagate, reduction occurs at cathode. So cathode is my positive electrode antanu antivi. Fine. Yes. Take the next point. Cu is becoming Cu plus 2. How? Cu plus 2 yavag agate when it gives 2 electrons. That means there is loss of electrons. Loss of electrons means oxidation. And where oxidation occurs? It is anox. So it occurs at anode. Electrons are deposited on it, therefore negative charge. Now, if I want to see the EMF of the cell, entire cell idu, ಎರಡು half cells idave, reduction half cell, oxidation half cell ide. If I want to see the EMF of the cell, ಹೆಂಗ್ represent ಮಾಡ್ತೀವಪ್ಪ ನಾವು EMF? We write it as E cell, correct? So how do I calculate the EMF of the cell? I'll write it as E cell is equal to E cathode minus E anode. Am I right? E cathode minus E anode. So, or in some books you can see, or E cell ಇನ್ನೊಂದು ವೇ ಒಳಗೆ represent ಮಾಡ್ತೀವಿ. ಹೇಗೆ? It is E right minus E left. E right minus E left, because right side is my cathode. Daniel cell ನೋಡಿದ್ವಿ in the last session. Right side ಅಲ್ಲಿ ಏನಿದೆ? Cathode ಇದೆ. Left side ಅಲ್ಲಿ ಏನಿದೆ? Anode ಇದೆ. So here when I say E cell, that is cell potential, I mean by default I'm talking about reduction potential. I'm talking about reduction potential. So I can also write as E cell is nothing but reduction potential which is taking place at cathode minus reduction potential which is occurring at anode. This also can be written. So it is just a convention. Whenever we say is cell potential, we are talking about reduction potential. Now the question arises, what is the difference between reduction potential and oxidation potential? Reduction potential and oxidation potential, the only difference is the difference of sign. Reduction ಏನಿರತ್ತಲ್ಲ, ಅದರ opposite sign oxidation ಇರುತ್ತೆ. If reduction is having positive sign, oxidation will have negative sign. If reduction is having negative sign, oxidation will have positive sign. That's it. Understanding? So here, so the difference is of only sign. That means if I get some E cell value bandbiಟ್ಟು, if I get 0.05, its reduction potential, its oxidation potential is 0.05. No, oxidation potential, standard oxidation potential, I am getting 0.05. What will be standard reduction potential? Tell me, what will be standard reduction potential? It will be minus 0.5 volts. Ashte. It is the difference of sign. Ashte. Okay, that is a convention. Fine. So I can write this reaction like this. Please see, E cell. So in terms of oxidation potential, sign changes agate. So here I'll write, instead of E reduction potential, minus E oxidation potential at cathode. Okay, right? Minus and as it is. E reduction potential of anode, how do we write? Minus E oxidation potential at anode. Is that right? Okay, just go on simplifying. How will you simplify? Minus E oxidation potential at cathode. Minus of minus ಏನಾಗುತ್ತೆ? Plus E oxidation potential at anode. Or the final equation, I can write E cell is nothing but minus sign ikade tagolona. So E oxidation potential of anode minus E oxidation potential of cathode. So this can be also in terms of oxidation potential can be represented. Otherwise, what I said, by convention, whenever we are talking about reduction potentials, we are talking about electrode potentials, we always consider reduction potential. So now, for our galvanic cell, let us take, so we or this example we'll consider. So E example ke we'll calculate E cell. Hey, calculate martivappa. So I'll write it here. Fine. So here E cell is what? E cathode minus E anode. Howda? So what is my cathode? Cathode. So here is my cathode. So I'll write it as E reduction potential baribeku. Reduction potential andaga ion modulu, then the solid metal, minus E. Here also reduction potential only. Cu plus 2 bar Cu. What does this mean? This means reduction of Ag at cathode, and here this means reduction of Cu at anode. So till here you understood that the cell potential is nothing but E cathode minus E anode. But now here we come across a problem. There is a situation now. Okay, a cell setup ಮಾಡಿದೀವಿ, entire cell EMF of a cell or a cell potential can be calculated. That will be standard cell potential, electrode potential na calculate ಮಾಡಿ. Now my question is, the problem is how to find the electrode potentials of the half cells. Half cells the electrode potential ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು? How do you determine the half potentials, the cell potentials of the half cells? Half cells cell potential ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು? Electrode potentials. Okay, see, that means I want to find electrode potential at cathode or electrode potential at anode. ಯಾಕೆ or ಅಂತಿದ್ದೀನಿ ಹೇಳಿ? Because if I can know electrode potential of cathode using E cell value from the table, I'll show you the table, we can calculate the other one. If I know anode, I can calculate cathode. If I know cathode, I can calculate anode. Now my question is how to calculate any one of it. E anode ಅಥವಾ E cathode ಹೇಗೆ calculate ಮಾಡೋದು? How to determine electrode potentials of the half cells? To solve this problem, we have in our picture something called SHE. Yes. What does this SHE stands for? It stands for standard hydrogen electrode. Stands for standard hydrogen electrode. ಕೆಲವೊಂದು books ಅಲ್ಲಿ NHE ನು ಬರೀತಾರೆ. It stands for normal hydrogen electrode. Okay, but most of the times we use SHE. Yes, so using standard hydrogen electrode, we can calculate the electrode potentials of the half cells, whether it is oxidation half cell or reduction half cell. So now let us see how it is designed and what is with the help of SHE, how we can find the reduction potentials of the half cells. Okay, so to understand this SHE, first we need to understand the working of and the construction and the working of SHE. Fine. Okay, fine. So here oxidation. So this is what we have seen. Yes. So here we have SHE. You can see here standard hydrogen electrode, which is normally also known as normal hydrogen electrode, NHE. It consists of this glass tube. See, this is actually a reference electrode. SHE is actually a reference electrode, because we use it as a reference. We'll come to know why it is a reference electrode. Okay, with the help of which we can determine the electrode potentials or reduction potentials of the half cells. Okay, reduction potentials of the half cells, if we want to determine, we use this as a reference. Okay, fine. So it behaves, see, very important point about this SHE is that this standard hydrogen electrode can behave as anode as well as cathode. It can behave both as anode as well as cathode. Now the question is how it can behave as anode or a cathode. How it will behave as an anode or a cathode. We'll see it. Fine. Okay. So see, now that's very interesting. Okay. So let's see here. Cathodic half cell andaga. When we talk about a cathode half cell, so what happens at cathode? Red cat, reduction occurs. So at cathode, there must be reduction, and reduction is gain of electrons. Okay. So H plus hydrogen electrode, it is H plus, will gain electron. H plus, which is in the aqueous form, will gain electrons and forms H2. So I'll balance it. I'll write half H2. Yes, this is in the gaseous form. So it has gained the electron. So here you can see, on the other hand, if you talk about anode half cell, if it is behaving like a cathode half cell, this is what going to happen. On the other hand, if you are talking about anode half cell, what happens at anode? At anode, oxidation occurs. Oxidation occurs. So oxidation is what? Loss of electrons. Fine. So H2, which is in gaseous form, will lose an electron and form H plus, which comes into the solution. So it will lose electron. So balance it. So this is anodic half cell. So it can work both as cathode half cell or as anode half cell. Further interesting point about this SHE, Further interesting point about she is that the electrode potential, whether I'm talking about standard oxidation potential of this SHE or standard reduction potential, the electrode potentials. So I'll write it like this. Oxidation potential andaga E naught. What do I write here? I write it as oxidation. Oxidation is what? Loss of electrons. So E reaction hogatte. So half H2 bar H plus. Or when I talk about standard reduction potential, where reduction takes place. So E naught H plus bar half H2. Correct? The standard oxidation potential or the standard reduction potential of SHE is assigned the value of 0. It is assigned the value of 0. In both the cases, oxidation potential early, reduction potential early, it is assigned standard electrode potential in general. The value assigned is 0. It is 0. That's the reason I said it is used as a reference electrode. Understanding? Now let's see what happens in SHE, the construction and working of SHE. Now you have this half cell reactions. Using this half cell reaction, can I write the cell representation? The cell representation for SHE. What is the cell representation? We write it as PT, here as subscript solid, a vertical line. Then you have H2 in the form of gaseous. Then we have H plus in aqueous ions. So this is the cell representation. This is the cell representation for SHE. So what is the construction of this SHE? Let's go into the construction. Okay, fine. You can see here, this is standard hydrogen electrode. Okay. Here you can see this is a glass tube. So here we take a glass tube and in it we take an inert platinum electrode. Why platinum? Why platinum is used? Because platinum absorbs. Why platinum? Because platinum absorbs. Therefore, in our cell representation, we had platinum. Platinum absorbs hydrogen gas. That's the reason we have taken platinum. So this is platinum. Okay, finely powdered, finely divided platinum is coated. Platinum black is coated. In fact, here we write platinum black is coated on a platinum foil. Okay. At the top of the glass tube, there is a slit. This is a slit. New slit andri, athwa you call it as an opening. Okay, there is a slit. For what reason there is a slit? It is for the for passing H2 gas. So the slit is through which pure hydrogen gas is passing. Now here all the standards have to be maintained. So the name standard hydrogen, yes. So this pure hydrogen gas, it is at 1 bar pressure. 1 bar pressure. This is bubbled into the solution, okay, through this particular glass tube in which you have platinum. Okay, so when you bubble pure hydrogen gas through the slit inside, what happens is when H2 gas is bubbled inside, this particular platinum will absorb the hydrogen. Okay, it will absorb the hydrogen, and the excess H2, that is how much platinum can absorb, it will absorb. Jasti absorb madakagala, how much is required, that much we will eat, yes or no? Jasti absorb madakagala. So how much a platinum can absorb, it will absorb hydrogen gas, and the excess hydrogen gas, it is given out, it is bubbled out. You can see the bubbles coming out here. The excess hydrogen gas is bubbled out. So this excess hydrogen gas is bubbled out where? It is bubbled out into the solution. Here is an important thing. What is the solution actually? The solution is acidic. The solution is acidic. Yenappa, to be more specific, we have taken hydrochloric acid. We have taken hydrochloric acid. 1 molar concentration of HCl. Therefore, we have represented H plus. Solution is acidic. Fine. So basically, so see, during this entire process, hydrogen gas is entering through the glass tube, platinum is absorbing, platinum absorb ಮಾಡ್ತಾ ಇದೆ. So platinum is absorbing and the excess hydrogen gas is given out. So what is happening here? So it is dissociating anbodu into the solution. So what is getting here, I can represent it here. H2, it is being, excess H2 is coming out into the solution as H plus by losing electrons, correct? And this H plus from the solution, it is going into the it is gaining electron. Sorry, let me make it very clear. It is gaining electron and becoming H2. So loss of electron, oxidation, gain of electron, reduction. Is that clear? Yes or no? Fine. So this is one side oxidation is occurring and the other side reduction is occurring. So basically when this is going on, so hydrogen is getting absorbed by platinum in the form of H2, and at the other side from its H2, it is dissociating into the solution as H plus. So when basically a stage is reached where equilibrium is established between the two. Equilibrium is established between the two andaga, equilibrium is established between H2 and H plus. So at this stage, we said equilibrium is established. So this is where we see one side oxidation is occurring and the other side reduction is taking place. Now we are going to see how using this SHE, we are going to measure the electrode potentials of the other half cells. Is that clear? So this is our experimental setup. The wire is sealed in glass tube placed in a beaker containing 1 molar solution. Hydrogen gas at 1 atmospheric pressure is bubbled through the solution at 298 Kelvin because standard temperature. So in SHE, at the surface of platinum, either of the following reactions can occur. So only we said SHE can act as a cathode and it can act as anode. If it is acting at cathode, what is happening here? H plus ions, they are taking electrons to form H2, or if it acts as anode, H2 loses electrons to form H plus. So electrode potential has been fixed as 0. The standard reduction potential, how I can say, the standard reduction potential of SHE, it is assigned to be 0 at all temperatures. It is assigned to be 0. Either you are talking E0 H plus bar H2 or E0 H2 bar H plus, it is 0. Fine. Now what is its drawback? The drawbacks are, it is difficult to maintain 1 atmospheric pressure. It is difficult to maintain 1 atmospheric pressure for hydrogen gas. Yes, quite obvious. It's difficult to maintain H plus ion concentration 1 molar. The platinum electrode is easily poisoned by the traces of the impurities. So these are the, what you can say, drawbacks. And usually this standard hydrogen electrode, it is taken as primary electrode, primary reference, because ಇಲ್ಲಿ reference ಅಂತ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ we have two references, primary reference and secondary reference. So because of these drawbacks, you take calomel electrode, it is used as reference, secondary reference electrode ಅಂತ ಅನ್ಬೋದು. Okay, fine. Then calculating the EMF of the cell, as we have discussed earlier. How do you calculate the EMF of the cell? So electromotive force anta antivi. Fine. Difference between the electrode potentials of the two half cells cause flow of current from electrode at higher potential to the electrode at lower potential. It is also measure of free energy change. Standard EMF cell is denoted as E0 cell. Standard E0. So E0 cell is what? E cell andre hege baritivi? E cathode minus E anode athwa E right minus E left. Standard electromotive force anta andaga we use E0 cell is equal to E0 cathode minus E0 anode. That is nothing but E0 right minus E0 left, where E0 is what? Standard EMF of the cell, standard cell potential. For numerical purpose, always take E0 right and E0 left values as standard reduction potentials, as I have said. Assume ಮಾಡ್ಕೊಂಡು ಬಿಟ್ಟಿರ್ತೀವಿ, it is taken by convention, sorry, rather than assumption, let me use the term by convention, it is taken as always. Cathode potential, electrode potential ತಗೊಳ್ಬೇಕಾದ್ರೆ you take reduction potential only. Anode reduction electrode potential consider ಮಾಡಬೇಕಾದ್ರೆ you take reduction potential only. Fine. Differences between EMF and cell potential is given. ಯಾವಾಗ ನಾವು ಅದಕ್ಕೆ EMF of a cell ಅಂತೀವಿ, or when we call it as cell potential. Potential difference between the two electrodes when there is no current drawn through the circuit. When there is no current flowing in the circuit, we use the term EMF. But if there is any current being drawn through the circuit, we call it as cell potential. Potential andaga current ಬಗ್ಗೆ ಮಾತಾಡಬೇಕಾಗುತ್ತೆ. EMF is maximum voltage which can be obtained from the cell. It gives maximum work obtained from the cell. Here, cell potential is always less than maximum voltage. The work obtained is less than maximum work from the cell. EMF is measured in potentiometer. Cell potential is measured in voltmeter. Yeah. Okay. So here you can see Daniel cell being represented. The cell representation is given Zn solid bar Zn plus 2, which I had explained. The double bar represents half cells in a separate marta idivi ankolbodu, or this double vertical line also represents what? It also represents the salt bridge. Fine. Okay. So reaction is being given, complete reaction. So here we have anode which acts as cathode, sorry, anode, zinc acts as anode, copper acts as cathode. Standard cell potential calculate ಮಾಡಬೇಕಾದ್ರೆ E naught cell is equal to E naught cathode minus E naught anode. ಯಾವ್ದು ತಗೊಳ್ತೀವಿ? Reductions. Therefore Cu plus 2 bar Cu, and they have taken the values. I'll just show you the values here. We have values. See, you can see these values. ಈ values ನ ತಗೊಂಡ್ಬಿಟ್ಟು if you substitute there, you will get the answer. So ಏನ್ values ತಗೊಂಡಿದಾರಪ್ಪ? Cu plus 2 ಇಂದ it is becoming Cu. So where is my Cu plus 2? So this is there. Cu plus 2, it is becoming Cu. What is the value? The value is plus 0.34. So plus 0.34 value is there. Then you have Zn. So Zn plus 2, Zn is becoming minus 0.76. So you can write it as E naught cell is equal to E cathode minus E anode anta baribodu. And here it will be cathode value eshtiде. It is E cathode 0.34 minus of minus 0.76. So when you solve it out, it becomes minus of minus and plus agate. So here you get the answer. You get the answer. That is what being is shown. Using the values, you can write. Using the values, you can find the electrode potentials, and that is being shown here, right? So here we have it. So see here. It is 1.1 volt. So plus 3.34 minus of minus 0.76, minus of minus becomes plus. So standard cell potential is 1 point of a Daniel cell. Please do remember this particular point. The standard reduction potential, standard cell potential of a Daniel cell is 1.1 volt, where you have taken zinc copper couple. Okay, fine. So here using, now we are going to see how using this sheet we are going to find the, or we are going to measure using the standard hydrogen electrode, how we are going to measure the electrode potential of the another half cell. Okay, let me consider an example. So let me say I want to measure the electrode potential of magnesium using sheet. So to understand this conceptually, let us first have to understand, we have to first understand the logic and the experimental setup anta anbodu. If you want to understand it conceptually, how to find andaga, you need to first understand the logic and the experimental setup. Okay, so I say I want to measure electrode potential of magnesium using SHE. So I want to find electrode potential of magnesium. I need what? I need a cell setup. Really, I have two half cells, oxidation half cell, reduction half cell, only cathode half cell, or anode half cell, only, that doesn't make a difference. I need a cell setup. That means I want an electrochemical cell. So for the cell setup, I need two electrodes. So here one should be magnesium electrode. So one should be magnesium electrode dipped in its electrolytic solution. So dipped in MgSO4 solution anbodu. MgSO4 ಎಷ್ಟು ಇರಬೇಕು? Standard conditions. So 1 molar MgSO4 solution ಅಲ್ಲಿ dip ಇರಬೇಕು. And the other hand, you have hydrogen electrode which is dipped in HCl, 1 molar HCl solution. Fine, 1 molar HCl solution, right? So solutions in both the cells will be 1 molar because it is in standard conditions. Atmosphere H2 at atmospheric pressure, how much? 1 bar pressure ಅಲ್ಲಿ ಇರಬೇಕು because standard. So it should be at 1 bar pressure, and the temperature conditions should be at 298 Kelvin. It should be at 298 Kelvin. So the setup is ready. My setup is ready. So we have connected these two electrodes using wire, and we have placed a voltmeter. Why voltmeter? Because voltmeter it reads what it reads. It reads the cell potential. E cell read ಮಾಡ್ಲಿಕ್ಕೆ ಬೇಕಲ್ಲ. It will tell me the value of cell potential. Therefore, to measure the reading, I want voltmeter, that is also being connected. But the question is, So you are going to measure the electrode potential. You want to measure the electrode potential of magnesium. The question here is, which electrode is anode and which is cathode? Howda? See, I know that this is very, very fantastic person. She will act as anode as well as cathode. ನಿಮಗೆ ಹೇಗೆ ಬೇಕು ಹಾಗೆ ಬಳಸ್ಕೊಳ್ಬಹುದು. ಬಟ್ ನಾ ಕ್ವಶನ್ ಇಸ್, ಮ್ಯಾಗ್ನೇಷಿಯಂ ಎಲೆಕ್ಟ್ರೋಡ್ ನ ನೀವು ಕ್ಯಾಥೋಡ್ ಆಗಿ ಬಳಸ್ತೀರಾ ಅಥವಾ ಆನೋಡ್ ಆಗಿ ಬಳಸ್ತೀರಾ? Let me say, what do you mean by anode? What is actually happening at anode? Oxidation has to take place. So anode is an electrode where oxidation occurs. Oxidation andre ಏನು? Loss of electrons ಆಗಬೇಕು. Who will lose electrons? Who can lose electrons? ಯಾವುದು more reactive ಆಗಿದೆ, that will lose the electrons. Am I right? We have studied this in elements ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ, more reactive element will lose the electron. So illi, when you compare both of them, both the electrodes, which is more reactive? Reactive series prakara magnesium is more reactive. You can go in this form also. Athwa ಏನ್ ಮಾಡಬೇಕು, by assumption you have to proceed. magnesium ne ನಾನು anode ಆಗಿ ತಗೋತೀನಿ ಅಂತ assumption ಮಾಡಬೇಕು. But here, to be more specific, I know that magnesium being more reactive, so magnesium will lose electrons. So magnesium is a metal, it is more reactive than hydrogen, and it is having more SRP value, negative SRP compared to hydrogen. That will find, we are going to find that. So I'll not use that particular sentence. So magnesium will lose electron and form Mg plus 2 by losing 2 electrons. Therefore, what I can say here is, it undergoes oxidation. It is losing electrons. ಯಾವ particular substance oxidation ಆಗತ್ತೆ, it will undergo oxidation ಅಂದ್ರೆ it helps in reduction ಅಂದಾಗ ಅರ್ಥ. So I can say which undergoes oxidation gets oxidized and will reduce the other. Therefore, magnesium is a good reducing agent. It is a good reducing agent. Why good reducing agent? Because it will help in reduction. Gain electron gain ಮಾಡ್ಲಿಕ್ಕೆ help ಮಾಡ್ತೈತೆ. ಹೇಗೆ help ಮಾಡತ್ತಪ್ಪ? It is going to give electrons. So it is helping in reduction and itself getting oxidized. Itself undergoing oxidation. Getting my point? So itself undergoing oxidation ಅಂದಾಗ ಯಾವುದು electrode ಆಗಬೇಕು magnesium? It should be anode. That means it will be an element which will reduce the other element, comparatively stronger reducing agent, which means its reduction potential value will be negative. Its reduction potential value will be negative. There is reduction potential negative because more reducing agent adu. So anode, oxidation, negative potential value, and it should be a good reducing agent. Is that clear? So more the negative value of reduction potential, more will be the reducing power. So that will be a better reducing agent. On the other hand, cathode hatra enagutte? Cathode hatra reduction agutte. So reduction means gain of electrons. So more positive means what? Cathode will have that element which is having positive SRP. Yes or no? It will have positive SRP. And my hydrogen into the table just now we saw positive SRP baratte. So this is very crucial concept. If you understand this, everything gets crystal clear. You need to understand this particularly. Measure ಮಾಡೋದಿದೆಯಪ್ಪ half cell. How will you do that? Which one you will consider as cathode or a anode? Fine. So here we move to one step ahead now. See, we have hydrogen and magnesium. So in case of hydrogen, in case of SHE, what is SRP of SHE? SRP of SHE by convention, SRP of SHE by convention, it is taken to be 0 volt. It is taken to be 0 volt. Now I'll tell you, SRP of magnesium from the table, if you see, its value is minus 2.36. Its value is minus 2.36. Okay. So which means magnesium electrode will be my anode. See, I'm correct. Anode. Magnesium electrode will be anode. So how will you represent? And SHE will be cathode. SHE will be cathode. And magnesium will be anode. Fine. Now, cell representation hege ಮಾಡ್ತೀವಿ? We write it as Mg solid bar Mg plus 2 in aqueous form. Aqueous form andaga, to be more specifically, since we are talking about concentrations and all, I'll mention it as 1 molar concentration, correct? The double bar H plus 1 molar H2 at 1 bar pressure. And here we have taken platinum solid because it provides a surface. Platinum yake? Because it provides a surface on which our electrode is present. Fine. So what will be the EMF of this cell? So E cell is equal to E cathode minus E anode. Okay, at standard conditions, because I've taken 1 molar concentrations, 298 Kelvin temperature, 1 bar pressure, hydrogen is being maintained. Therefore, E naught cell is equal to E naught cathode minus E naught anode. Is that right? So, cathode we have SHE and its value is 0 minus. What is the value of anode? Mg we have taken, it is minus 2.36. So, what will be my final answer of E naught cell? Standard cell potential ಎಷ್ಟು ಬರುತ್ತಪ್ಪ? It is 2.36 volt. Is that clear? So this is E naught cell value what we have got. Why I told this is because using the EMF of the cell, we can measure the electrode potentials of cathode or electrode potential of anode. So E cell, how we'll get this E cell? We'll get this E cell through the experimental setup. We'll use 2 beakers. Ondralli SHE irutte, SHE setup ಮಾಡಬೇಕು. ಇನ್ನೊಂದರಲ್ಲಿ you will have another magnesium electrode in MgSO4 solution. You have a salt bridge ಎಲ್ಲ setup ಮಾಡಿದಾಗ ಇಲ್ಲಿ voltmeter fix ಮಾಡಿರ್ತೀರಿ. That will give you the value of E naught cell. Correct? So E naught cell value ಸಿಕ್ಬಿಡ್ತಪ್ಪ. SHE value is 0. So you find the value of Mg. ಅದೇ formula here. You can use this formula. Minus E naught anode is equal to E naught cell minus E naught cathode. Solve it out and put the negative sign for it. You will get the value. Yes. So E naught cell ಎಷ್ಟು ಬಂತಪ್ಪ? 2.36 minus E cathode ಎಷ್ಟಿದೆ? 0. So answer is 2.36. Is it 2.66? No. This sign has to be transferred. So it is minus 2.66. So E naught anode value ಎಷ್ಟು ಬಂತಪ್ಪ? Minus 2.36. Observe it in the table. Is it minus 2.36? Yes, of course it is minus 2.36. So what does this mean? The value of E naught cell electrode potential Mg plus 2 standard reduction potential of magnesium is minus 2.36 volts. Means what? The reduction power of Mg is high. What does this mean? Reduction power of Mg is high. That is, it reduces others and itself gets oxidized. What we have discussed just now, which also means that in comparison to hydrogen, that metals or magnesium's reduced form is less stable. It will not go into its reduced form. ಯಾಕಂದ್ರೆ ಅದು ಕಡಿಮೆ ಸ್ಟೇಬಲ್ ಇರೋದ್ರಿಂದ it will not form its reduced form. It will not get itself reduced. It will itself gets oxidized. It will reduce others and itself gets oxidized. This is very, very important. If you want, you can consider one more example where we will be calculating, we will be measuring. Let me say, let me take an example. If I want to measure, okay, measure electrode potential of copper using SHE. Okay. So table namak solpa reactivity table namak solpa gothirbeku. SHE andaga we have hydrogen. Fine. So reactivity series table alli if you see here hydrogen is here and you have copper here. Fine. Okay. Ee reactivity series namak solpa nenpalidre tumba help agutte. It becomes easier for us to move. Okay. So as I said, you need to actually find or you have to take it by convention anta helidana. So here, let's assume convention, assumption in the hogona. Let's assume that SHE is my anode here. Okay, let me assume that SHE is anode and copper is my cathode. Let me assume like this now. Copper is my cathode. So how do you represent this cell? So cell is represented like this. Platinum in solid form, bar H2 gas, 1 bar pressure, bar H plus, aqueous, 1 molar concentration, the double bar Cu plus 2 in 1 molar concentration, bar Cu solid. Fine. This is the cell representation. Now, if I want to calculate the cell potential, standard cell potential, E naught cell is equal to E naught cathode minus E naught anode. So what is my cathode reduction potential? Consider madbeku. So it is E naught Cu plus 2 bar Cu minus E naught H plus bar H. Okay. I don't know my E naught Cu plus 2 bar Cu. So I'll keep this value Cu plus 2 bar Cu minus what is the standard reduction potential of SHE? It is 0. And what is E naught cell? See, E naught cell of Cu plus 2 bar Cu. It is 0.34 plus 0.34. Fine. So can you see here? It is plus 0.34. Okay. So let's move to the calculation part. Fine. So it is E naught cell yesterday 0.34. Okay. So here E naught Cu plus 2 bar Cu is equal to 0.34 plus 0. Shifting this side, which is nothing but it is 0.34 volts. I am getting the value in positive. That means observe carefully here. The answer is in positive. Okay. So positive value means what? SCP is standard electrode potential of an electrode is greater than 0. Standard electrode potential of an electrode is greater than 0. Yes or no? Greater than 0 only. Or you can say it is a positive value. Then a positive value. So what does that mean? It means its reduced form is more stable than compared to hydrogen gas. So you can see here plus 0.34 answer bandide. So whatever I had assumed that copper is cathode, that is also true. Copper being cathode electrode. Getting? So reduced form of copper is more stable. That's what is happening. Copper is cathode. So that is more stable. So reduction occurs. So Cu reduction, Cu plus 2 will take the electrons, gain ಮಾಡುತ್ತೆ and it will form Cu. Is that clear? Okay, fine. So here we have electrochemical cell applications. The lower the value of E naught reduction, this is another way of how you represent standard reduction potential. The greater is the tendency to form cation. Andre yenu, the greater is the tendency to give electrons. Okay. The metal undergoes oxidation, loss of electrons on the oxidation, and itself and is a reducing agent. And it is a reducing agent. It will undergo oxidation and it will reducing agent antandrenu, it will help in reduction and itself gets oxidized. So Mn plus N electron. M is undergoing oxidation, that is a reducing agent. If that particular metal is undergoing oxidation, it is a good reducing agent. If that particular metal is undergoing reduction, then it is good oxidizing agent. Metals placed below hydrogen in the electrochemical series replace hydrogen from dilute acids. But metals placed above hydrogen cannot replace. ಅದನ್ನೇ ನಾವು ನೋಡಿದ್ವಿ in the example. More stable forms ಮತ್ತು less stable forms. So if they are above hydrogen, they will replace hydrogen from the acids. But if they are below hydrogen, they cannot. Example, zinc ತಗೊಳ್ರಿ with dilute H2SO4, it will form ZnSO4 and displace hydrogen gas. Iron you take, it will displace hydrogen gas. The same thing, because the zinc and iron, they lie above hydrogen in the activity series, reactivity series, ಅಥವಾ electrochemical series only. But if you see copper ತಗೊಂಡ್ರಿಯಪ್ಪ ಅಂತಂದ್ರೆ Cu plus H2SO4, there won't be any reaction because copper lies below in the electrochemical series. Or you take silver, gold, if you put it in any acid, there will be no reaction. Hydrogen gas is not displaced. It is not feasible. Such reactions are not feasible because Cu and Ag lie below H2 in the electrochemical series. Okay. Oxides of metals placed below hydrogen are not reduced by H2, but oxides of iron and metals placed above hydrogen are reduced by H2. So here SNO, PbO, CuO, etc. they are reduced by H2. Whereas calcium oxide, potassium oxide, sodium oxide are not reduced by H2. Reducing character increases down the series and oxidizing character decreases down the series. Reducing and oxidizing are vice versa. La? So as you go down the series, electrochemical series, reducing character kadme aagta hogta hai. I'll show you the electrochemical series. At the top, what are the values? At the bottom, what are the values? And top and bottom is separated by hydrogen. I'll show that. F2 is the best oxidizing agent having maximum reduction potential of plus 2.87. Positive value bandide andre it is a best oxidizing agent. Please mark this point. If you are having SRP value positive, it is a best oxidizing agent. If the SRP value is negative, it is the best reducing agent. Andre SRP value positive ideyappa, oxidizing agent agi it will behave as an oxidizing agent. Andre oxidation help ಮಾಡುತ್ತೆ, electrons na ಕಳ್ಕೊಂಡು oxidation help ಮಾಡುತ್ತೆ, itself gets reduced. Reducing agent agi which particular element will work because SRP is negative. Reducing agent anta andre it will help in reduction for gaining of electrons, attan electrons na kodutte, itself gets oxidized. ಕೊಟ್ಟಾಗ electrons na ಕಳ್ಕೊಳ್ಳುತ್ತೆ, yes or no? So itself gets oxidized. So here Fe is the best oxidizing agent. Yes. Lithium is the best reducing agent as it is having least standard reduction potential, that is minus 3.05 volt. Okay, applications continued. So reactivity series increases down the series. Metallic character, you can see down the series. Determination of EMF. Determination of EMF is what? EMF is difference of reduction potentials of two halves. EMF, EMF anta bariri, E cell anta bariri, cell potential ಮತ್ತು ಯಾವಾಗ ನಾವು cell potential ಅಂತೀವಿ, ಯಾವಾಗ EMF ಅಂತೀವಿ, I've told you. When no current is drawn, it will be EMF. When some current is drawn, it is cell potential. Fine. So EMF ಅಥವಾ E cell is equal to ERHS minus ELHS ಅಂತ ಯೂಸ್ ಮಾಡಿ. NCERT ಅಲ್ಲಿ E right minus E left ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, or E cathode minus E anode, because in our electrochemical cell at the right side is cathode and at the left side is anode. E cell is positive, then the cell reaction takes place spontaneously, otherwise no. Okay. If E cell is less than 0, the cell reaction is non-spontaneous and the cell does not work. If E cell is equal, then the cell reaction is in equilibrium. This is what we have seen. Greater the reduction potential of a substance, greater the oxidizing power. Greater the reduction potential. Hege adu minus linda 0 positive aagta hogutte, that becomes a good oxidizing agent. Therefore I told you it is a better oxidizing agent anta. Lesser the reduction potential of a substance, greater is its reducing power. Hege reduction potential kadime aagta barutte, that will be a better reducing agent. Oxides of metals having standard reduction potential more or equal to 0.79 will be decomposed by heating to form O2 and metal. Example, HGO. This particular reduction potential values yelli use agattappa, it is used for converting a particular metal. Now extraction of metals ಮಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ oxide form ಅಲ್ಲಿ ಇರತಕ್ಕಂತ metal na reduce ಮಾಡಬೇಕಾಗುತ್ತೆ. So you will be using reducing agents there. Moreover, other forms ಅಲ್ಲಿ ಇದ್ದಿದ್ದನ್ನ oxide form ಗೆ convert ಮಾಡ್ತೀವಿ. Oxide form na if we convert it to metal, which is not pure metal, it is crude metal. So here it becomes useful. So you can see here HGO, it is an oxide of mercury, cinnabar anbodu. HGS inda HGO bandirutte. So this HGO, see, it is heating, it is decomposing to Hg plus O2. So it is giving oxygen and there is metal getting formed. You can see here the reduction potential. Reduction heading, you're looking at the subscript, you can see reduction, standard reduction potential Hg plus 2 bar Hg is 0.79. Positive antandre enu, it is a good oxidizer, it is having a good oxidizing power. Electrochemical cells are extensively used for determining pH of the solutions, solubility product, equilibrium constant and other thermodynamic properties. Fine. So this is my electrochemical series. You can see these are having positive SRP values. So standard reduction potential values are positive. Therefore, they are weak reducing agents ಅನ್ಬೋದು ಅಥವಾ they are strong oxidizing agents ಅನ್ಬೋದು. Yes, or strong oxidizing agents. Strong oxidizing agents. But as you move down, what is happening? The positive value is decreasing. Standard reduction potential value is decreasing as you move down. It is becoming negative here. Yes. So what is happening? Oxidizing agent power is going on reducing, and reducing power is increasing. So at the bottom line, you have the elements which are strong reducing agents, and this is the differentiating line on both. So you can see here, standard reduction potential of SHE is what? It is 0. Yes, it is 0. So using these values, these are the values of E naught cell. So using these values, you can find E naught cell value. Okay, you can find E naught cell value. So reduction potential values, these are standard reduction potential values. So you, at the starting, you have positive values which say that SRP positive oxidizing agents. At the bottom, you are having negative values. So just now we had seen F fluorine is strong oxidizing agent because it is having positive value, right? Whereas lithium is a strong reducing agent because its SRP value is least minus 3.04. So this is about the electrochemical series. Electrochemical series. So it gives you what? It gives you decreasing standard reduction potential values. Decreasing standard reduction potential values. So this is all about, on the other side it is written like this. You can see as you move at the top, oxidizing nature is more. At the bottom, reducing nature is more. So this is all about electrochemical series. Hope up to this the points are crystal clear. In the next session, we'll be moving on to the next part, very interesting parts of electrochemistry, that is Nernst equation. What are the applications of Nernst equation, electrolytic cells, conductors, all the things we'll be discussing. So for now, up to this, concepts are clear, I feel. Thank you.